So, hi guys! Welcome back sa akin channel. Ito yung Lab Design and Implement, a VLSM Addressing Scheme. So, may dalawa tayong router dito and dalawang switch. So, for BR1, meron tayong 40 hosts. For BR1 to BR2 link, meron tayong 2 hosts. And for the BR2, meron tayong 4 subnets. BR2 LAN, 25 hosts. BR2 IoT LAN, 5 hosts. BR2 CCTV LAN, 4 hosts. BR2 HVAC C2 LAN, 4 hosts. So for the objectives, Part 1, examine network requirements. Part 2, design the VLSM address scheme. Part 3, cable and configure the IPv4 network. So for short background, VLSM or variable length subnet mask was designed to avoid wasting IP addresses. With VLSM, a network is subnetted and then resubnetted. So, yung instructions, Part 1, examine network requirements. In Part 1, you will examine the network requirements to develop a VLSM address scheme for the network displayed in the topology diagram using the 192.168.33.128 with the prefix of 25 network address. So, Step 1, determine how many host addresses and subnets are available. So, how many host addresses are available in a 25 network? So, we will borrow the remaining 7 0 bits. So, 2 raised to 7 is equal to 128 host address. Then 128 minus n, which is the network address and broadcast address. So 128 minus 2 is equal to 126 usable addresses. So total number of host address needed in the topology program is 80 because 40 plus 2 plus 25 plus 5 plus 4 plus 4 is equal to 80. Then how many subnets are needed in the network topology? So ayan, 1, 2, 3, 4, 5, 6. Determine the largest subnet, step 2. What is the subnet description? So for VR1 LAN, we have 40 hosts. So we have 2 bits here. So 128 plus 64 is equal to 192. So for the BR1 to BR2 link, we have 2 hosts. So we have 6 bits here. So 128 plus 64 plus 32 plus 16 plus 8 plus 4 is equal to 252. So how many IP addresses are required in the largest subnet? 40 IP addresses. 40 hosts. What subnet mask can support that many host address? So 255.255.255.192. How many total host addresses that can that subnet mask support? So we have 6 remaining 0 bits. So 2 raised to 6 is equal to 64 minus the network and broadcast addresses, which is 62 usable addresses. So can you submit the 192.168.33.128 with the prefix of 25 network address to support the subnet? Yes. What are the network addresses that would result from the subnetting? 192.168.33.128 up to 191 with the prefix of 24. So use the first network address for the subnet, 192.168.33.128, prefix of 24. So step 3, determine the second largest subnet. What is the subnet description? BR2 LAN, 25 hosts, so we have 3 bits here. So 128 plus 64 plus 32 is equal to 224. How many IP addresses? So we have 25 hosts, so 25 IP addresses. What subnet mask can support that at many host addresses? 255.255.255.224. So how many total host addresses and can that subnet mask support? So we have 5 remaining 0 bits. So 2 raised to 5 is equal to 32 minus network and broadcast addresses, which is 30 usable host addresses. So can you subnet? Yes. The network addresses that will result from this subnetting is 192.168.33.192 up to 223, prefix of 27. So this is the first network address for this subnet, 192.168.33.192, prefix of 37. So step 4, determine the third largest subnet. BR2 IoT LAN, which has 5 hosts. So we will borrow 5 bits here. So 128 plus 64 plus 32 plus 16 plus 8 is equal to 0.248. How many IP addresses are required? So we have 5 hosts, so 5 IP addresses. What subnet mask can support that many host address? 255.255.255.248. Then how many total host address? So we will borrow the remaining 3 0 bits here. So 2 raised to 3 is equal to 8 minus network and broadcast addresses, which is 6 usable addresses. So can you subnet the remaining subnet again? Yes. What are the network address that would result from the subnetting? 192.168.33.244 Prefix of 28. Use the first network address for the subnet, 192.168.33.244, prefix of 28. So use the second network address for the CCTV LAN. BR2 CCTV LAN has 4 hosts, so we will borrow 5 bits, which is 128 plus 64 plus 32 plus 16 plus 8, which is equal to 248. So the remaining 30 bits, 2 raised to 3 is equal to 8 minus network and broadcast address, which has 6 usable addresses. So the usable host addresses is 192.168.33.233 up to 258, prefix of 28. So the network address is 192.168.33.232, prefix of 28, and the broadcast address is 192.168.33.239, prefix of 28. So use the third network address for the HVAC C2 LAN. So BR2 HVAC C2 LAN has 4 hosts. So we will borrow the 5 bits here. So 128 plus 64 plus 32 plus 16 plus 8 is equal to 248. So the remaining 30 bits is 2 raised to 3, which is 8, minus network and broadcast address, which has 6 usable host addresses. So the usable host addresses are 192.168.33.241 up to 246, prefix of 28, and the network address is 192.168.33.240, prefix of 28, and the broadcast address is 192.168.33.247, prefix of 28. So this is the last step. Step 5, determine the fourth largest subnet. For BR1 and to BR2 link 2 hosts. So we will borrow 6 bits. So 128 plus 64 plus 32 plus 6 plus 32 plus 16 plus 8 plus 4 is equal to 252. So how many IP addresses? 2 IP addresses. So what subnet mask can support that many host addresses? 255.255.255.252. How many total host addresses can that subnet mask support? So we have 2 remaining 0 bits. So 2 raised to 2 is equal to 4 minus network and broadcast address, which is equal to 2 usable host addresses. So can you subnet the remaining subnet again? Yes. What are the network addresses that would result from this subnetting? 192.168.33.248 up to 251. So the usable host address is 192.168.33.249, prefix of 30. So use the first network address for this subnet, 192.168.33.248. So part 2, design the VLSM address scheme. Step 1, calculate the subnet information. Use the information that you obtain in part 1 to fill in the following table. So yung mga nakuha lang natin dito sa part 1, kinompile lang natin dito. So for BR1 LAN, network address is 0.128. The first host address is 0.129. Broadcast address is 0.191. So yung next niya ay 192 for BR2 LAN. Then the first host address is 193. Then the broadcast address is 223. So yung next is 224 for BR2 IoT LAN. First host address is 225. Then broadcast address is 231. So yung next is 0.232 for BR2 CCTV LAN. Then first host address is 233. Then broadcast address is 0.239. Next is 240 for BR2 HVAC C2 LAN. Then the first host address is 241 and the broadcast address is 247. The next one is 248 for BR1 to BR2 link. Then the first host address is 249 and the broadcast address is 251. Step 2, assign the first host address in the subnet to the Ethernet interfaces. BR1 should be assigned the first host address in the BR1, BR2 link. So itong table na to, gagamitin natin ito mamaya. I-assign natin siya sa Gigabit Ethernet 000 and Gigabit Ethernet 001 for both routers. So ito yung mga IP addresses na and also the subnet mask. And also, lalagyan din natin siya ng description later on. Part 3, cable and configure the IPv4 network. In part 3, you will cable the network to match the topology and configure 3 routers using the VLSM address scheme that you developed in part 2. So punta tayo sa Cisco Cat Tracer. So ito yung PC natin. May dalawa tayong PC dito. So lagay natin yung isa natin PC dito. Then lagayin lang natin yan sa topology. So switch 1, BR1, BR2, switch 2. Then So, ayan. For the first one, gagamit tayo ng copper straight through table. So, i-connect natin yung switch 1 dito. Sa F05, so fast Ethernet 05, to gigabit Ethernet 0/1 ng DR1. So, 0/1. So, ayan. Then, next, copper straight through ulit. Gigabit Ethernet 00. Gigabit Ethernet 00 to Gigabit Ethernet 00 of DR2. So, dito. Then, for BR2, Gigabit Ethernet 01 to Fast Ethernet 05 ng switch 2. So, ayan. Then, gagamit tayo ng console dito. So, for the console, coconnect natin siya sa PC1 ng BR1 to the RS232 of PC1. And then, another console for the console of BR2 switch to the PC2. So, turn on natin. Then, on din natin yung router. So, ayan. Pupunta tayo sa next step. Configure the basic settings on each router. A. Establish a console connection from the terminal window of the PC. Then, assign the correct device name to each of the two routers. So, assign class. Assign syscos the console password. Assign syscos the VTY password. Then, encrypt the plain text password for the routers. Then, create a banner MOTD. Then, so ayan, punta tayo ng PC1, then terminal, then click OK. So, for the router, enable, then config key, then hostname, BR1, then line, console 0, then password, Cisco, then login, exit, then line VTY 0 to 15, line VTY 0 to 15, then password, Cisco, login, exit, then enable secret class, service, password, encryption, banner, MOTD, authorize access only. Then exit, then show run. So ayan, nakalagay na yung hostname natin as BR1, then service password encryption. Then ayan, may banner MOTD na rin tayo. Authorized access only. Then next is show IP int brief. So i-assign natin yung Gigabit Ethernet 000 and Gigabit Ethernet 001. So dito siya. So itong BR1. So i-assign natin siya. So config key int G000, then IP add 192.168.33.249, subnet mask is 255.255.255.252, then description is BR1 to BR2 link. So, ayan, no shutdown. Then, exit. Then, int G001. Then IP add 192.168.33.129. Subnet mask is 255.255.255.192. Description 40 host LAN. So no shutdown. Then show IP int brief. Show IP int brief. Show IP int brief. Show IP int brief. So ayan, na-assign na natin yung gigabit Ethernet interface for 0 and 1. So ayan, nakikita natin siya dito. Then ayan, so copy, run, start para ma-save lahat. So yes, then okay na, building configuration. So next one is the BR2. So ito yung sa BR2 natin. 250 and 193. So, kung tayo sa PC2, terminal, desktop programming, then router, okay. Enable, config T, hostname, BR2, then line con 0, password, Cisco. Login, exit. Then line VTY 0 to 15, password Cisco. Login, exit. Enable secret class. Service password encryption. Then banner MOTD authorize access only. Then ayan, exit, show run. So ayan, makikita natin yung hostname is BR2, then service password encryption is enabled, then may banner MOTD rin tayo. So next one is show IP int brief. So wala pang naka-assign sa gigabit Ethernet 0 and 1. So i-assign natin siya. So config T, then int G0/0/0 IP add 192.168.33.250. Subnet is 255.255.255.252. Then description is BR2 to BR1 link. Then no shutdown. Then exit. Next is int G00/0/1. IP add is 192.168.33.193. Subnet is 255.255.255.224. Description is 25 host LAN. Description 25 host LAN. Then no shutdown. Then exit. So ayan. Tapos save natin. Copy, run, start. Okay. Exit. Then copy, run, start. So, upon seeing here, yung completion is 100% na. So, check natin yung results. So, assessment items, check na lahat siya. Nagawa natin lahat nung pinapagawa sa lab na to. So, 41/40. So, next step is test connectivity from BR1, ping gigabit Ethernet 0 to interface ng BR2. So, ipiping natin to mamaya. Itong dalawa. So, punta tayo sa PC1, ang BR1, terminal. So, ping on BR2. Okay. Ito, piping natin yung 250. 192.168.33.250. So, ayan, isa pa. Ping 192.168.33.250. So, ayan, 100% na. So, check naman natin yung isa sa PC2. Terminal, okay. Piping naman natin yung sa BR1. So, ayan. Ping 192.168.33.249. So, ayan, 100%. So, konektado sila. So, can you think of a shortcut for calculating the network addresses of consecutive prefix of 30 subnets? So, ayan, ito yung ginawa ko. Kunyari, 192.168.1. So, we all know that prefix of 30 has 4 network addresses. So, meron siyang 2 usable host address, 1 network address, and 1 broadcast address. So, example, the IP address is 192.168.1.0, prefix of 30. So, subnet A, 0, first host add, 0.1, broadcast add, 0.3. For subnet P, yung next ng 0.3 is 0.4, then first host add is 0.5, broadcast add is 0.7. Then next is 0.8 for subnet C, then first host add is 0.9, broadcast add is 0.11. For the next one is 0.12 for subnet D, then next is 0.13, then broadcast add is 0.15. So that's the end of the experiment na to.